there are a number of examples, and the book goes through a number of examples. And in fact, every textbook goes through a number of examples. That's an exaggeration. Not every textbook. Sorry about that. Of constant acceleration. But if acceleration is not constant, in other words, the time derivative of acceleration is not zero, then calculus is involved. Well, if acceleration is constant, then I expect velocity to be a function of time, a linear function of time, and displacement to be a quadratic function of time. So some clues are if v is not a linear function and displacement is not, or position, depends on how you want to work it out, is not a quadratic function of time, then acceleration is not constant and calculus is involved. So let's just take a simple example of if velocity is equal to 2 meters per second plus 3 meters per second t minus 4.9 t meters per second. Let's see, this should be meters per second squared and meters per second cubed. So that is my initial acceleration. That is my jerk. In this case, the jerk is constant, but my acceleration, which is time derivative of velocity, becomes 3 meters per second squared minus 9.8 meters per second cubed, because the constant doesn't change, times t. And my displacement, well, technically, my position is going to be the initial position plus the antiderivative of velocity with respect to time. Now, at this point in Calc 2, I don't know if you've gotten to integrals or not, but my understanding from past classes is that in Calc 1 you do antiderivatives, and that's just reversing the process. So I have 2, the antiderivative, and this is just the symbol telling me antiderivative, and that tells us the variable. So 2 plus 3t minus 4.9t squared. So what do I need to do in order to get 2 as my derivative? Well, that would be 2t. Here, again, you add 1 to the exponent, so that's t squared, and then you divide by the new exponent. And so minus 4.9t cubed over 3. And so that would be this whole bit right here. And so that is my displacement is equal to that. If I brought this over, I'd have displacement. And then I'd have to give some boundary condition in order for you to have a formula for position. But it's as simple as that. Just the biggest problem students have on this one is the calculus aspect of it. So if I have a t to the n, if this is my function, then if I do my antiderivative of that function, that would be, well, you add 1 to the exponent and then divide by the new exponent. Because when you take a derivative, you multiply times the exponent here, that's going to cancel out with this, and then you subtract 1, and that puts you back here. So if I have square root of t, don't forget that's t to the 1/2, and so the antiderivative of the square root of t dt is, well, I add 1, so that makes it 3/2, and then I divide by 3/2. Now that's too many fraction bars there, so that's 2t to the 3/2 over 3, and that's an acceptable answer. Plus some constant, because there's always some constant, plus some constant. Yeah. Oh, technically that's the constant right there. And I'm hoping this is enough of a reminder, and I guess I'll get questions if people are really not familiar with antiderivatives. If you've gone through Calc 2, we're talking integrals. If you're just starting Calc 2, again, antiderivatives, and at some point you'll get to integrals, and you'll go, oh, okay, yeah, that's easy.